problem here, just because there's a piece in this problem, in particular this function, that makes things a little tricky that I just want to resolve. It's something that I guess you should learn in pre-calculus, but I don't know which class goes through this idea. But we want to understand what this function looks like, and or what this function is here, and it has this absolute value over x part, and that can be described in a certain manner. So, and then we want to take the integral of this function. We'll find out, once we know what this function kind of looks like, exactly what this integral is. So the first thing we want to look at in this is that we have absolute value of x over x. And if we just take some time to realize what happens with the absolute value of x over x for any x, or as we go along the x-axis. So I'm just doing this on the side. It has nothing to do with really calculus, I guess. Again, I think it's a pre-cal concept maybe, but if we choose various values of x, let's see what happens to the absolute value of x over x. So what happens to the absolute value of x over x in this case? So if I choose a value over here, let's say a, right? Or let's choose various values. Let's say a, b, and 0. Okay, so 0 is a key one for x. And then c, d, right? I don't know. Let's just make another one, e, right? It doesn't matter. And let's see what's happening in each one of these cases so we get a sense of what the absolute value of x is over x. So in this case, a is negative, right? So if I wanted to find out what the absolute value of a over a would be, well, in this case, the top part would just be positive a, right? It would be the negative of this, which would be, a is a negative value here. It could be like -3, right? So then that means that this would be negative a at the top, negative -3, right? So let's just pick an actual value. That'll make it easier, right? So let's say x is -3. Then we'd get the absolute value of -3 over -3. And the absolute value of -3 is just 3 over -3. And then this would be -1. And what you should start to see is that if I picked any value over here, let's just make it -2. Let's not do it in the abstract. -2, right? Then it would be -2, absolute value of -2, over -2. And the absolute value of -2 is just 2 over -2. And you'd get -1 again. And you should see that for any value over here, any negative value for x, so if x is less than 0, this absolute value of x over x is just -1. And I'll just do a rough sketch of that. It's just the constant function like this, right? The horizontal line. And you could pick any value, right? Like the absolute, like if I said x is -5, the absolute value of -5 over -5 is just -1, right? Because you get +5 on the top and then -5 on the bottom. Now this switches when you pick positive values for x. So let's say 1, I don't know, 3, 5, 7, it doesn't matter. So what happens when we pick positive values for x? Well, positive values for x are going to be the absolute value of 1 over 1. But the absolute value of 1 is just 1. So it's 1 over 1, and I get 1 right there. Let's say this is 1, positive 1. If I say 3, the absolute value of 3 is just 3 over 3 is just 1 again. And I'm going to get 1. And we should see that for positive values of x, we just get this horizontal function, like this. And then it's not defined when x is 0, okay? X is 0, you divide by 0, it's 0 over 0, that's just going to be undefined. And this is what the actual graph of absolute value of x over x looks like. It looks like a horizontal line at -1 for values that are less than 0, and then a horizontal line at +1 for values greater than 0, and then again not defined at 0. How do you incorporate this into this function that we're dealing with here? Well, the way to see this here as is saying that it's going to be for negative values of x, this is just -1. this blue part that I circled. This absolute value of x over x, look, for negative values of x, it's just -1, right? It's always -1 for values. And then for positive values of x, it's just +1. So there's a way to rewrite this entire function that's going to help us out. So we could rewrite f of x as a piecewise function, where to start, this absolute value of x over x is just going to be -1 times x squared minus 1. And this is if x is less than 0. And then the absolute value of x over x is just 1 if x is greater than 0. So that just becomes x squared minus 1 if x is greater than 0. And again, the whole thing here is that for f of x, it's not defined at 0. So let's just get a sketch of what f of x roughly looks like. We should know generally what our parabolas look like, and it's going to switch at 0. So I'm going to try and do it on this little graph just to give us an idea as best I can, a rough sketch of what's happening here. So I have negative x squared plus 1 when I distribute the -1 into this one. So negative x squared plus 1 looks like this. Here's +1 up here, let's say, and it's a hollow dot because it's not defined there. Negative x squared looks like this, right? And then x squared minus 1 for values greater than 0. Here's -1, right? It starts off at -1 along y, and then it curves upward like that. And this is roughly what this is actually exactly what this whole function looks like. Okay, these two are exactly the same thing, and it's just interpreting this part that's actually tricky, right? This absolute value of x over x, very like unique, right? Very strange. So now let's get an idea of how we perform this integral. Okay, so you want to break up the integral into two pieces. So it's from -1 to 2 of f of x dx. But we need to see that, and we want to break it up along where it's defined. So from -1 to 0 of f of x dx plus, this is equal to, right? We should see this as equals using our rule, our properties of a definite integral, from 0 to 2 f of x dx, because that's going to allow me to use these two pieces of f at different points, right? First I'll use this piece, and then I'll use this piece, right? Because it's broken up along the 0 line, right? This is the f. I'm going to use this piece because the x values are less than 0 in this the bounds of my integral, right? I'm going to be integrating from -1. I think -1's right here, right? -1 is a solution to that. -1 squared is 0, yeah. So -1 right here, right? To 0 along this one, right? So I'll be integrating that area in this case, in this integral. Then I'm going to use this piece, right? And I'm going to find the area underneath the curve from 0 to 2. So from 0 to 2, 2 is over here, right? So this is 1 right here. And I'm going to be looking at this area plus whatever is over here for this here. Okay? And I'm going to find out what these integrals equal. Okay, so for this first piece, right, I'm using this piece. So I want to integrate from, let's write that up here, let's say. I want to integrate from -1 to 0 of -1. The -1 can come outside, so it's -1. Don't forget to multiply by -1. -1 x squared minus 1 dx. And then plus the integral from 0 to 2 of just this piece, right? So now the values of x are positive except for the 0, but you don't care. That doesn't matter. This discontinuity, you just kind of ignore it, right? You still integrate from 0 to 2 and from -1 to 0, right? Of this x squared minus 1 dx. Now, to integrate this, we want to use the fundamental theorem of calculus. We want to remember that if I take an antiderivative for this here, and we'll go over this more if we haven't gone over this enough, we need to find an antiderivative for x squared minus 1. An antiderivative for x squared is x cubed over 3 minus an antiderivative for 1 is just x. And I put now, instead of the integral sign of an s, I put -1 to 0, and I have to remember to multiply whatever I get when I plug in these bounds. Okay? I have to multiply by -1. So it's from -1 to 0. So I plug in my upper bound, I get 0, minus my upper bound, I plug in 0 for x. 0 cubed is 0, minus 0 is 0, minus the lower bound. -1 cubed is -1, -1/3, minus -1 is +1. I'm minusing that whole thing, right? -1 cubed is -1/3, minus -1 is +1. Subtracting this whole thing from 0, so you could distribute the minus to get -1 plus 1/3. In this piece, right, don't forget the -1 all the way in the front. Keep track of this. Don't make the arithmetic mistake that I might be making somewhere in this. Okay, -1. This is negative 2/3. And then times the -1, your answer is positive 2/3 for this first part. Okay, and that makes sense that it's positive because this is an area above the x-axis. This part here, right, from our picture. So positive 2/3 plus. Now I have to find out what this one is. I already have the antiderivative. The antiderivative is x cubed over 3 minus x. And then I plug in 2. I'm going to get 8/3. 8/3, not 8 to the third, right? 2 cubed is 8. So it's 8/3 minus 2. And then this becomes what? 8/3 is, or 2, this is 6/3, right? Yeah, this is 6/3. So then 8/3 minus 6/3 is 2/3. But now, to me, they should not be equal. Maybe they are. And then the whole answer would be 4/3, and B would be your choice. Let's make sure, because I'm looking at this picture, and what this is saying is that this region should be equal to this region. So these two should cancel each other out. This is saying that this region here, the integral from 1 to 2, is just 4/3 actually. Why? Okay, so let me just get confidence in my answer. So there's a lot of arithmetic involved. It helps to know theory well. I argue that this region here is equal in area to this region. So these two regions cancel out, right? Then that means that the answer to this integral is just the integral from 1 to 2 of this first one. Maybe if I saw that originally, I could have simplified it. So I'm going to see if this from 1 to 2 of just x squared minus 1 dx, that should be equal to immediately 4/3 if I did this correctly. So let's see, x to the third over 3 minus x. And then I plug in 2, and then I minus the 1. So 2 is going to give me 8/3 minus 2 minus 1/3 plus 1. So I'm doing this quick. I'm doing the arithmetic quick. This is 7/3 minus 1. 7/3 minus 1. This is 1 is 3/3. 7/3 minus 3/3 is 4/3. So I got it in the other way. If you can see how it is that I figured out that this integral is equal to the integral that they're asking, that's great. Okay, I saw that these two regions were symmetric, so and one's negative and the other one's positive, so I knew that they were going to cancel out. So then I knew that the answer to this integral would just be this region here. So I integrated from 1 to 2, and I got the same result in both cases as 4/3. Okay, now let's do another one where we also are asked with this weird x minus 1 over the absolute value of x minus 1. So similarly, right, we need to investigate what x minus 1 over the absolute value of x minus 1 is. So it's going to be a similar thing, but there's just going to be a different switching point. So the switching point in this case is when x equals 1. Why is it when x equals 1? Well, look, let's say I pick a value to the left of 1. To the left of 1, right, these two things are to the right. Let's say to the right. Let's say 2, right? 2 minus 1 over the absolute value of 2 minus 1. Well, that's just going to be 1 over 1. Because 2 minus 1 is 1. The absolute value of 1 is 1. And then this is 1. So I'm going to get 1 up here. To the left of 1. Let's say for 2, right? So I'm going to get that value up there. Then let's say I chose 3. And I'm going to get the same thing. I'm going to get 1, right? And now if I pick 1, I get an undefined. But then if I pick something to the left of 1, let's say 0. 0 minus 1 over the absolute value of 0 minus 1. And this is where things switch, because now you get a negative 1 in the top, but a positive 1 in the bottom, because 0 minus 1 is negative 1. The absolute value of negative 1 is 1. So then now you get negative 1 over 1, and then here at 0, you get negative 1, you get this point, and anything to the left of it. So here, you get this arrow going that way, and then up here, you get the arrow at 1, the horizontal line at 1. And it just says that this f of x, right, this piece, you can forget about, and you can just say that f of x is also equal to the piecewise function, right, of, it's just going to be negative x plus 2, because this thing that I boxed, right, for x values to the left of 1, if x is less than 1, right, this just becomes negative 1, this whole part. And if x is greater than 1, then it's just x plus 1, because that whole piece that I boxed there is always just 1 if x is greater than 1. And this is what's going to allow me to evaluate this integral. It's going to be much easier now. In this case, I don't need to know antiderivatives to evaluate this integral, and I can just use areas. I can find the area underneath the curve, but I'll just practice finding antiderivatives and using the fundamental theorem again. So I have, let's make it a different color. Let's say pink. So I want to find out the integral from negative 1 to 3 of f of x dx. And I want to use properties of integrals again. I want to say from negative 1 to where it switches, which is at 1 of f of x dx, plus from negative 1 to 1, and then you're going to go from 1 to 3. And that's the same thing as this integral. That's properties of definite integrals. And this is, why am I splitting it along 1? Well, for this integral here, it's for values less than 1. And then for this integral here, it's for values greater than 1. So I use this here for this part. So I'm going to get negative, the integral from negative 1 to 1 of x plus 2 dx, plus the integral from 1 to 3 of x plus 2 dx. And now I have, let's see, so now I just want to find out what these integrals are. It's negative 1 times, right, from negative 1 to 1 of the antiderivative of x is x squared over 2, and then the antiderivative of just 2 is just 2x, plus, and I'll plug in this one, it's 1 to 3, same antiderivative, x squared over 2 plus 2x. And maybe I could have drawn a sketch of what f actually looks like, and that shouldn't be too hard. They're both just lines that switch at 1, and it's not defined at 1, and there's probably a jump discontinuity. But okay, whatever. I mean, and I could have used that maybe to help me out with more confidence in this, but let's see what I get. So when I plug in 1, I'm going to get 1/2 plus 2 minus the lower bound value, which is 1/2 minus 2. And this is the whole thing is times -1 for this first integral. So what do I get here? This is 2 minus -2, so it becomes plus 2. So it's 4, and then the halves actually cancel, right? So it's positive half minus a half cancels, and then it's 2 minus -2. It's just 4. 4 times -1 is just -4. And then now I have to add this other piece here. So this other piece, right? I plug in 3, I'm going to get 9/2 plus 6 minus 1/2 plus 2. And I got to put that in parentheses. This is going to give me 8 plus this. What is it going to be? -4. So what do I got? I got -4 plus 9/2 plus 6. That's what? 9/2 is 4.5. Good. Okay, 4.5 plus 6 minus a half plus 2. And then this becomes a half minus a half cancels. I get 8. So something's not right. So I did something wrong. So then now I gotta sit here and I gotta try this again. Okay, I made a mistake somewhere. Probably in my computation of something in my arithmetic that I mess up. So let's go through the arithmetic again. I did this integral correct. The antiderivative, I did that for sure correct. Let's do it again. 1/2 plus 2. That's for sure right. Minus the lower bound. So take my time with the signs. 1/2 minus 2. Yeah, so this part is definitely 4. 2 minus -2 is definitely 4. So this part is 4, and then times the -1, it's definitely -4. So this part, I'm confident I got that integral right. Now let's do this integral again. So let's see. So 3 squared is 9/2 plus 2 times 3 is 6. That's me plugging in the upper bound minus the lower bound minus 1/2 plus 2. Okay, and I have to distribute this minus. Maybe I didn't do that. So this is 4.5 plus 6, which is 10.5. Minus a half minus 2. So minus a half cancels 10. This is 8. And this is plus 8. And then this is 4. So what did I do wrong here? I don't know. How did I get this? So the halves cancel. 10.5 minus a half is 10. Minus 2 is 8. So I got 8 for this one. And I'm adding these two together. So I did -4 plus 8 is 4. And my choice is B, 4. I would check it again. I would maybe even graph it if I had time to just check again to see if everything is good. Because now I got one answer that wasn't on there. And then I got another answer that happens to be on there. So just check. Take your time with the arithmetic. I run out of space. Be sure that this makes sense.